camera. Can you hear now? Great. So the camera is picking up the sound, not the whatever. As long as you can hear, that's the most important thing. Okay. Yeah. Okay. Great. We're back. People can hear. The funny thing was I had just done this whole thing about how this is only theatre where everything works and nothing else works at the university. And then you were like, nope, we can't hear you. So this theatre also doesn't work. All right. So today we're just going to do a whole bunch of linked lists. And, you know, just because you haven't had enough of linked lists with the assignment and the last few weeks. So thought we'd do some more today. And then that's it. And then it's just prep for the exam. And hopefully, you know, you're feeling confident or positive at least a little bit about the exam. I feel like the best thing about this exam is that, you know, it's all about doing the practice problems. You don't have to memorize pages and pages and pages of information. It's all about practicing problems. So if you've been doing your labs, go back and do them all again. And then we've made more revision exercises available, actually. I'll just show you where they are. Okay, so in week 10, we've got extra revision in here. In the extra content, there is a sort of a whole bunch of exercises that we've pulled out from some of them from old exams as well, so that you can also have some practice and revise a few things. So have a look at those when you've got time and work through them. There is also across all the different weeks. Oh, hello, Tom. Across all the different weeks, there is a whole bunch of revision exercises as well. So I strongly recommend that you do those. And that will help you. All right, Tom, could you please pop into, oh, you've already done that. Okay. Way ahead of the game. Too used to that. All right, and broken record, apologies, but my experience surveys are still happening. So I think there's one more week for them to go. Please fill out the My Experience surveys. They really let us make improvements to the course, and they let us make the course better for those people that come after you. We use the feedback, and it's also, I think, if you really liked your tutor, just write that down because it's really nice for them to see that feedback as well at the end of the year, especially. So please fill out the My Experience surveys, and you'll have some time in your tutorial classes to do that. And there's a link there, or there's also a link on the Moodle page. Okay, a bit more housekeeping. We are running revision classes in week 11. So basically we'll be working through a lot of those revision problems in class. You can ask any questions you want. You can come, you know, and you can vote on which topics you want to cover. So the tutors will do a little spill on that topic, and then you'll practice problems, because the best way to get better is to keep practicing problems. So there's 2 classes right now, Thursday 24th of November 2 till 4 p.m. And Friday 25th of November 2 till 4 p.m. is the face-to-face class, and the registration is over the Eventbrite page as well. And we will share that on the forum as well, so that you have access to that information. Okay, so I think it's time to really just do a problem and kind of work through a problem. So we'll do the first one that I used as an example, and I've written it out because last time some of the problems didn't have enough information, so or enough expansion on the spec. So I've written out what you will kind of see in the exam. The wording as well, and I guess you've seen it in the prac test, but a little bit more. So find the range, the difference between the biggest term and the smallest term of a linked list. So this here is kind of what it will look like, similar to it, and the amount of detail you will get in the exam. You'll get a lot of detail. You'll also get assumptions. And then I'll show you how to test it as well, because it's using something we haven't done this term in the course, which is your command line argument. So you enter things on the command line, but you don't really have to understand how it works. You don't have to understand why it works. You just have to be able to do it. Okay, so this is kind of similar to what you get. So find range takes one parameter pointed to the head of the list to search through. Find range should return a single integer, the difference between the range value, the smallest value, and the largest value in the list. For example, if the list contained 3, 4, 5, 6, then it should return 3 because 6 minus 3 is 3, and 6 is the largest and 3 is the smallest number in the list. Another example, if the list contains just one thing, then it will just return that one thing as it's the only value in the list. Okay, you'll also be told that potentially this function, this file contains a main function which allows you to test your find range function. So just like question 1, do not change the main function. If you try to change the main function, you have misunderstood the question, because what the main function is doing is it's taking the numbers that you type in on the command line and turning them into a list for you. You don't have to do it. All you have to do is pass through that list and find the range of the list. So don't change the main function, please, in the exam, or just if you're told don't change it, don't change it. So your actual function is called directly in marking, which means that the main that is included in that starter code is only to help you test your find range function. So if you do make changes inside that main, none of those changes will be marked because we don't call your main function, we call the function that we asked you to write. So please be careful with that. Okay, so basically this is how it works. You compile it as normal, but when you run it on the command line, you will do your usual name of the program, and then you will type numbers of the list that are spaced by a space, and it will convert it to a list that has 3, 4, 5 inside it. So in this case, it will return 2 because 5 minus 3 is equal to 2. Similarly, again, if you do it for a bigger list, it will just convert these things up here into a list for you. You don't have to worry about it. And then you just return the actual, what is the range? So 10 minus 1 is 9, so you'll return 9. And then if it's an empty list, so nothing is given, you should return the list is empty. Okay, and so then you'll also be given a whole bunch of assumptions and clarifications as well. So your function should return only a single integer, and that's the range of the list. Your function should not change the linked list it's given because we actually pass through the linked list and create the linked list for you. In this case, you're not inserting or deleting anything, so you shouldn't be changing the linked list. You should not change the next or data fields of the list nodes. So again, you're not modifying the linked list. You should not use arrays. We are pushing you to use linked lists in this question, and it's a hurdle, so please don't. You should not be calling malloc because you're not making any new nodes. You should not call scanf. You should not print anything, so you should not call printf. It's all kind of done for you. You shouldn't change the definition of the struct, and do not change the supplied main function. It will not be tested or marked. So then your starter code looks something like this, and I might expand it so you see it in all its full glory. So you'll see some sort of includes, then you might see a definition of your node, which you are probably used to seeing. Then you'll see your function that you are actually, we want you to actually write this function. So that's where you're writing, and then there's probably going to be a warning that says do not change the code below. So please heed that warning, do not change the code below. And it's got the main function that we do not want you to change. And this main function is the function that takes the input, and then it calls this function strings to list, which converts that command line to a list, so you don't have to worry about it. And then it actually prints everything out in the way that we wanted printed out, so you don't have to worry about forgetting to put a comma or a space, because it will print it out the way the auto tests for in terms of output, but you'll just have to obviously output the right number. So that's all you are doing. You are literally combing through and finding the range of the function. Okay, so what is the output if there isn't? So you just return this empty list, and then it will sort it out for you over here. So it says if the range, so if what you return is an empty list, it will print out the list is empty. So anytime you see an empty list, you want to return this empty list thing that is called. Okay, so should we write the function? How is everyone feeling about that? Okay, I guess you don't have to even know what the inputs and outputs of the function are because we are already we've already told you you're returning an int and you're taking in the struct. You're taking in the struct node head, so you're taking in the actual head of the list so you can pass through it. Okay, thoughts and ideas, bless you. Thoughts and ideas of how we're going to solve it. What do we reckon? Yeah, loop through, find the largest, loop through, find the smallest. Can we do it all in one go? Could try. Or we can do it in 2 goes. So we're not testing you for efficiency in the exam. I don't care if you loop through the list 7 times. It doesn't matter as long as you are setting the right variables and finding the right things. So we can do it both ways. Someone's asked also if we use things that are not taught in the course, is there any disadvantage in terms of marking? I mean, it depends what you're using. You're told what not to use. So, for example, in a linked list hurdle question, don't use an array. Other than that, you know, there is some opening, but you might make mistakes, especially in this first few questions. They're not meant to be complex questions. Okay, so we're going to be moving through the list. So I guess we'll start with our usual favorite struct node current is equal to head, so that we're ready to peruse the list. Is there anything I should check beforehand? Because I'm told for a specific boundary condition what to do. So is there anything that I want to check before I start moving my way through the list? Yeah. Hey. Current is not null. Yep, so we want to check if the list is actually empty. And I'm going to check it before I start anything. So I'm going to say if head is equal to null, which means the list is empty, then I'm going to actually just return empty list, which is what I'm told to return. And if you look up here in the hash defines, it says empty list is actually an integer, so that works for us because we want to be returning an int. So I'm going to return an empty list if head is null. Great. So that means I've taken care of what happens if it's an empty list. So now I'm ready to do something when it's not an empty list. So I've got my current, which is going to keep track of where I am in the list. And now I really want to somehow find the smallest number and also the largest number in the list. So what are some suggestions of how we are going to do it? What do we reckon? And feel free to pop it in the chat if you don't want to say it out loud. But we've done similar problems before in your tutes and labs. What do you do when you kind of have to loop through a big list of things and then find a smallest value? And how will I know that I've gotten to the smallest number?
We create a variable called smallest value, and if value in the current node is smaller than the smallest value, then you're trying the smallest value as the value given in node.
Yeah.
And you do the same for the biggest value.
Yeah, exactly. And it's a really commonly used thing that we use to sort through lists. We basically set the first item in the list to the smallest number or the largest number, and then we loop through it and we check, is the next one smaller than it? If it is, that's now my smallest number. Then I go on, check the next one. If it's smaller, then that's my smallest number. And it allows me to kind of comb through the whole thing and just reset every time I want to have a smallest or a largest. So I've got a smallest, and I'm going to set it to the first thing in my list, which is inside current data. And I'm also going to have a largest, and I'm going to also set it to current data. So what it's done is it's set both of them to the same values. So if I were to draw it for you, it would look something like this. So let's say we've got a linked list that is, oh, so close. There we go. Let's say we've got a linked list that says 3, 4, 5, 6. then what I've just done is I've checked that the list is not empty, which is great. I've said that this is going to be my current over here. And then what I've done is I've said the smallest is going to be what is inside that current data. So the smallest is going to be 3. And I've also said the same thing for the largest. Largest is going to be 3. So now I'm ready to start kind of comparing, moving through the list and comparing the different items in the list. Okay, so what do you reckon we should do as our condition? Should our condition go through every node or should it stop at the second last node?
Check if there's only a one node in the list, because I think I think when the output, if there's only one value given, it just prints out that one value.
It will, yeah, and we absolutely we will come back to it. I was going to make that a mistake. No, that's good. That's good. That's good thinking. So those are the things that we always have to be thinking about. Empty list, one item in the list, things are not in the list, and so on and so forth. So that's excellent. Well done. So what do we do if there's only one thing in the list? So we will, let's make a note about it. I guess I can't force that mistake now, but okay, and we'll check that it's working or not working. Okay, so if we're moving through the list, should we stop at 6 or should we go all the way to null? What do we reckon? Should we check every item? Should we visit every single node, or should we stop at the last node? We want to go all the way through because we want to check the last node as well. So that means we want to stop when we get to the very end, when we're at null. So whilst current is not equal to null, then we want to be doing something. And we've kind of discussed what we want to do. So as we loop through the list, we want to compare our data in the node to the smallest, largest. Okay, so let's do our comparison then. So if current data, so if the data sitting inside the node is less than smallest, then what I want to do is I want to make my smallest as the current data. So I'm changing my smallest. Okay, great. I'm going to go in one go. So else if current data is greater than largest, then I might want to change my largest to be current data because now it's the larger number. Okay, great. So, and what do I want to do here so that I don't get into an infinite loop? I want to move my node along. So I'm going to go current, current, next. Okay, and we'll see if we'll see how it works. Okay, and then what do we finish with? We might need to actually calculate the range. So int range is equal to largest minus the smallest. And we're going to be returning the range because we're returning the value of the difference between the largest and the smallest value. Okay, so if we compile it, yep. Hey?
No, wait, you didn't change it. You put current dash dash.
Ah,
yeah.
Look at this. Thank you. Good noticing. Okay, so it compiles. Okay, so now how I run it and test it is I do my usual output file and then I will do a list. So let's do 3, 4, 5, 6. So that means it should return 3 to me. It has, okay. I don't know, let's do a bigger list and it should return 7. Excellent. What are some other suggestions I should try to see if it works, the code works? All right, well, let's try the empty list, I guess, because that was one of our boundary conditions. Excellent. And then let's try the one with one value to see if it returns anything. Okay, so this doesn't work. So that means that we've forgotten one case. So we need to decide what happens if there is only one value. So here we've said if head is equal to null, return empty list. But what happens when there's only one item in the list? So how would we check for that? How would we know that there is only one item in this list? Yeah, so if head next is equal to null, so let's say head next is equal to null, that means that there is only one item in the list. So then I'm going to return whatever is the data in the head. Okay, let's see if that works. Okay, so now it's working for one item. But also, once you've made a change, just try it again for a few other things that you haven't broken something else, because usually you solve one thing, you break another. Okay, so then that's finding the range of things. What's going on? I've missed a whole bunch of things in the error in this tab. Thank you. Can we just return the calculation? You can absolutely. So over here, when we're returning the range, I can also just say, okay, could you just return largest minus smallest? And it will do exactly the same thing. So I don't have to have an extra variable. So you can absolutely do that. Negative numbers, we haven't tried negative numbers. What if you had numbers with decimals? Oh gosh, good question, but you would assume that there are no numbers with decimals because it's not going to read them properly, because we have said that inside our struct node, the data is an int, which is why we assume that it's going to be integers as opposed to decimal values. Okay, let's try negative numbers. So I'll do -3, -5 in here, and 10. So it should return 15 because the largest number is 10 minus -5 is 15. Okay, so it works for negatives. What about the same number? That's a good one as well. So if you do 3, 3, oh gosh, 3, no, 3, 3. Okay, and it's returning 0 because both of the largest and smallest are set to the first number, and none of the numbers were larger or smaller than that. So that works as well. So that was a good one to check as well. Excellent. Any other cases that you think might break it? I think we're pretty safe. And that means you've done it, you've passed another hurdle. As a question 2, and this is sort of indicative of the difficulty of question 2 as well. We'll do a few others that are similar as well. How's everyone feeling? Tom, could you please poll? Thank you. Now it's very complex. The other Tom is here. I'm going to have to go with Tommy again. Sorry, Tom.
If you want like halfway through, we can stop.
No, don't confuse. Oh, then the Tom 1, Tom 2 becomes confusing. So Tom used to admin that Tom. Yeah, and both of their surnames also start with a K. So I used to call them Tom 1 and Tom 2 when they're in the same room, and whoever's closest to me is Tom 1. That was the rule. That was always the rule. But then I just started calling you Tommy too, which is terrible because then Tammy, yeah. Just change names in 1511. Okay. In the corner, Tom, in the corner. Okay. Okay. Feels good. I hope that this is like boosting your positivity and confidence for the exam as well. Yeah. Okay. Let's do another problem. Maybe, do you want to work through them together or do you want to try them yourself? I know it's Wednesday morning. Give me something. I'm barely awake as well, but very awake. Together or try it yourself? Try yourself? Okay, let's do one try yourself. I have done, oh, this is a good one. This is not super hard. concatenate two linked lists. So join one linked list to another. And what I have done is I have not given you a detailed spec because it was all too much to do for all 6 problems. But just literally you're taking in 2 linked lists and you are saying you're joining them into one linked list. So for example, and again, I'm giving you the code and I'm giving you the way to test it as well. I'll show you how to run it to test it. But put your code here to concatenate. But basically what happens is if you get 2 lists and you would put them in as, let's say, I'm going to call it P2 as the name of the program, and the way you give the list 3, 4, 5, 6, then put a hyphen, and then, I don't know, 7, 8, 9. So those are the 2 linked lists. So let's say this is one linked list that you're given. This is the second one. Again, you don't have to worry about anything because we convert them to linked lists for you. What you should be returning, if you run that, you should be returning 3, 4, 5, 6, 7, 8, 9. So you should be returning the linked list that is just all as one. Okay, so try that. We will do the two dot. Don't worry, it's coming. I've got 2 lots of like question 4 type of questions. Just boosting positive vibes with 1 dots first. So that's a good question in the chat. Do we always join the second? Yeah, in this question, you will always join the second list to the first list, to the end of the first list. Yeah. So and think of all your special cases. You know, what if you're given first list and the second list is nothing? What if you're given nothing in the first list and then something in the second? Ghosts in this room. Feel free to raise your hand if you want to ask a question as well, and one of us will come up to you. That's where you got yourself into it.
Yeah,
So,
so I was like, oh, I have a question.
what's your question, Tom?
What is the meaning of life?
42.
Negative 42, that's right.
In week 10, yeah, negative 42
Yeah.
in week 10. We need a wake up chocolate. Yeah. There's more packets.
That's right. This is gonna be.
There's a lot of packets.
I have gummy bears. I have gummy bears. Someone in my class brought gummy bears.
Oh.
But I brought cake, so I guess they.
Oh.
All right. I'll say that. Okay. your brain, so you must have.
Hey?
Nothing. Oh, that's the side.
Next packet?
Yeah, we're gonna make it. Yeah, this is that. Thank you. Sure.
All right, how's everyone feeling? Did everyone get it? Should we solve it together as well? My gosh, just nothing.
Yeah, let's solve it together.
Yes, let's solve it together. Teamwork, teamwork, teamwork. Okay, let's do it. Okay, we've got two lists this time. So we want to be able to comb through, well, what do we want to be able to do? How are we going to solve it? If we want to go through the first list and add it to the end of it, what do we want to be doing? I kind of just said what we want to be doing. Just want to traverse the first list till we get to the end and chuck the next list onto it. Let's do it without considering the boundaries to start with. Okay, let's just do it for like a simple, everything is perfect, life is great. We've got two lists that have values in them, something that kind of looks like that. Okay, so I'll start out by having a current that will let me keep track of where I am in the list. I'm going to do it for the first list because that's going to let me keep track to get to the end of the list. Okay, now in this case, where am I going? Am I going all the way to the end of the list where it finishes here on a null, or do I want to stop at the last node in this case? Yeah, I want to stop at the last node because otherwise I won't be able to connect anything. I won't know where on earth I am. So I'm going to do my while expression, and it's going to be whilst current next is not equal to null. So whilst it's not, I'm going to, you know what, this is going to get, no, I'm going to leave it as this because then we're going to fix it for boundaries. Okay, so whilst current next is not equal to null, I'm just going to move it along. So I'm going to do current is equal to current next. And that means that when I come out of this while statement, I am sitting on the last node in the first list. Okay, fantastic. So if I'm sitting on the last node in the first list, I'm now ready to make my connection. And that means that my current, my current next is going to be equal to head 2. So I want my current next to be pointing to head 2. Excellent. All right, let's see what happens now. Let's compile it. Okay, it compiles. I might just clear this so that it's not. Okay, so now let's do two lists. 1, 2, 3, 4, 5, 6, 7. Okay, and it's working. 1, 2, 3, 4, 5, 6, 7. Fantastic. I feel like I've achieved so much. But now how can I break it? Okay. Let's try empty lists. Okay, let's do 2 empty lists. Just that's a hard no because we've just got nulls and nulls, nothing. We're dereferencing null pointers everywhere we go. So 2 empty lists is not going to cut it. And if we look at the issue, again, you're accessing a field via a null pointer, which means you're dereferencing a null pointer. I'm sure many of you have seen this issue happen over and over again as you've been working in your assignment. I'd be surprised if you haven't seen this yet. And it's happening over here because I haven't checked what happens if my list is equal to null. So probably we need to check before we do all of this whether the first list is equal to null. So let's check. So if my head 1 is equal to null, then what do I want to do? Return head 2. Very good. Okay, let's try that. So compile and let's run it. Okay, and so now it's just returned an X. It's returned a whole bunch of nothing, which is what we want. Okay, so what else do we want to try? Let's try one with nothing. Okay, that works. Let's try the first one with nothing, the second one with something. That's probably... Okay, so that works as well. Anything else that you can think of? Yeah. Or is that it? We've really kind of tried everything that we could. We've tried an empty list. We've tried the other empty list. We've tried both empty lists. So that's all seems to be working quite nicely. So perhaps this is, perhaps this is all working now. Okay, let's try another one. And okay, let's do one more 1 dot before we move to a 2 dot. Okay, last one of the 1 dots. Given 2 linked lists, return the difference in the number of items in the 2 lists. Oh my God, I really should stop writing questions late at night. That makes so little sense. Okay, what I'm saying is count up how many things there are in list 1, count up how many things there are in list 2, and return the difference between the 2 lists. So how many nodes in list 1, how many nodes in list 2, and then the difference between them. That is what that means. So for example, let's say in the problem 3.1, if we have list 1 is going to be 3, 4, 5, 6, 7, that has 5 nodes. And then let's say we've got list 2, and list 2 is 1, 2, 3, then it's got 3 nodes, so you will return 2. Okay, I don't care if it's really just to practice how to solve it. I haven't written a clarification, and obviously you can see if you've got the opposite way around, you're going to have a negative number. Don't care if you have a negative number, just subtract the first one from the last one kind of thing. So the number of nodes in the first list to the number of nodes in the second list. Okay, so maybe do you want to try it yourself? And then Tom, if you can poll if the concatenating was okay. Thank you. And then let's try it yourself for, I don't know, 7 minutes, and then we'll do it all together as well. And so again, you'll get this function that will convert everything into 2 lists that you've seen before. You don't have to worry about it. You don't have to, you just do the actual function that finds the difference. Everyone's feeling great. And here's code. Right. Oh yeah, one more minute. Okay. All right. Okay. How's everyone going? Who's done it in the room? Hands up. Hands up, hands up, hands up. Yay. Thank you. Yeah. That's exactly what's going through my head. Okay, do it together, or are you happy to move on to a 2 dot? Do together? Okay. All right. All right, let's do a quick run through together then. Okay, So we've got two lists and we want to count up how many things there are in each list. So I'm just going to do it in a, maybe not the most. So I'll have a current to keep track of my first list, and I'll have a current to keep track of my second list. Okay, so now I've got two lists and I've set my current 1 to the head of the first list. I've set my current 2 to the head of the second list. Okay, so first thing I want to do is I want to count up the number of nodes in it. And let's think over here after we do just a normal one, boundaries. What are some boundary cases? So that we don't forget. Okay, so let's comb through the first list. So what else do I need actually? Right now I can't really. Yeah, I need a counter. Excellent. So I need a counter for the first and the second one. So int counter 1 and int counter 2. Okay, am I going to go all the way through the list or stop at the last node? All the way through? Yeah, all the way through, because I want to count the last node. So whilst current 1 is not equal to null, what I'm going to do is I'm going to move it along. And I want to increase my counter. Which counter? Counter 1. Okay, so when I come out, that means I'll know how big the first list is. And then I will count up the second list in a very similar way. So whilst current 2 is not equal to null, I'm going to move along and I'm going to move the second thing along as well, the second node list. So not counter, current. Okay, and then finally we want to return the difference between the two lists, so counter 1 minus counter 2. 3. Okay, this will break, will it not? It will break. When will it break? It will not break then, but it will break in another case. I'll show you. So let's compile it. Okay, so compiled. Okay, let's do just a 1, 2, 3, 4, and 1, 2. Okay, so it'll give me a 2. If I do the opposite way around, so 1, 2, and then the second list is bigger, then it's just going to give me minus 2. When will it break? Yeah, so let's try an empty list. What if I give it an empty list and, I don't know, even one list? Oh, how nice. Okay, didn't break then. What if I give it nothing at all? Oh, hasn't broken. Why is it doing that? So why do you reckon it's not breaking?
Because it does not even enter the loops. And if it doesn't enter the loop, then both counters are set.
Exactly. So my expressions are whilst current 1 is not equal to null. So if it's equal to null, I'm not going into this loop. I'm not going into this loop. And my counters are both already initialized to zeros. So when it comes down to here, all I'm doing is just doing 0 minus 0 and returning a 0. Yeah? So sometimes try all those different cases, run through it, and see what is happening. Okay, should we move to problem 4, 1055? Actually, before we move to problem 4, maybe a good time to take a few minutes break. Because problem 4, yeah, we'll get you to log in. We're going to solve it together on, Tom will share a link in the chat. So for those of you, you might have to log into the YouTube to get the link. And we're going to work on the code together. Could be a mess, could be super fun. Why not? Week 10. Okay. Oh, I should log in as well.
It's really funny if you don't log in because then everyone else has to change it for you.
Yeah, well, maybe I won't log in because it feels too hard basket to log in. But I'll change it here once you get something that is functioning. I'm gonna bring it up. I don't know how. Oh my gosh, I'm just gonna enter the. Okay, so I'll get you all to log in. Oh God. Oh yeah. Where's the chat?
Yeah, the chat's there. It's open. Oh, no. Scroll down. Just below. That's the chat. That empty box.
Well, why isn't it?
Oh, I bet it's like blocking something. That seems awful. You open it in a browser that isn't run by Microsoft.
No, because I'm worried it's gonna crash everything.
Can you make your record public and then just have to log into the network? Like the actual. Yes.
I don't want to log in. I don't want to log in.
Yeah, I mean, all you can just tell what it is. You just change logins. Oh, yeah. Really not here. No login. Oh, sorry. Hash. Map.c. If you make a change, do you want to full screen? Or refresh? Yeah, maybe. Wait, normally. You know, you try to tell me not seeing it.
To log in.
You can try. Oh yeah, the only thing I think of is try clicking on main.c again. Just make sure to change her yes. Just change her yes. Make sure it's broadcasting. You only got part of it.
All right. All right. Let's come back. Let's we have time to do both of the 2 dots. I've got two dots. Okay, so we thought maybe we'll do the 2 dots all together. So I think Tom's shared a link. Feel free to log in, and then we can, I don't know, just pile on the code, and that might be more fun. See how we go. Okay, so again, you get a whole bunch of files, start a file. This one does printing for you as well, converts whatever you enter on the command line to a linked list. And what, just you can have a look, what it's doing is it's asking for a value to insert. And then I should probably show you what the problem is, because otherwise that's really unhelpful. Where did I have the problem? Here. Okay, insert a specified number into the middle of a linked list. Assume that there is always going to be an even number of numbers in the list before insertion. Okay, I'm making the problem a lot easier by saying there's always going to be an even number of numbers, so you can insert right in the middle. Okay, so then what your code is doing, this starter code, is it's asking for a value to insert, and then you enter the linked list on the command line. So it's going to look something like this. So you'll compile it and then you'll run it, P4, you'll give it a linked list. So it's got an even number of nodes, and then you will enter in what you want to enter, and then it will return 1, 2, 6, 3, 4. So usually these 2 dots, they're the harder questions. That means you're going to be either mallocing some memory or you will be killing some memory. So you're either inserting or deleting. And that's like the extension of the linked list, the harder thing to do with the linked list. So let's try inserting, and then I've got one as well that's deleting, so we can try a bit of both. Okay, so insert in the middle. What are your thoughts, ideas, suggestions? Do I know how many people are logged in? 11 people, 16 people. Could be anyone. Okay, so let's do it. What do you reckon should be the first thing to do? Yep. Sounds good. We should count the number of nodes. So at some stage, we want to count the number of nodes. Always remind yourself to think about boundary conditions. And for us, that might be empty list. Yep. Excellent. Okay. Okay. At some stage, we will also have to create a node by mallocing some memory. Okay, and then we'll have to insert it at the halfway point. Okay. Does anyone else want to write a line of code? Yes, someone's in. I was like, is it Tom? Oh, here we go. Okay, good. So doing the first boundary, what happens if that list is empty? Okay, so if the list is empty, then we just insert that number into the list, don't we? So how will we do that? Maybe we should create the node first, and then that will help us to, then we can insert. So should we create our node first? This is hectic. Yeah, okay. Someone is getting ready to pass through the list by setting the current. Okay, what about creating a new node? Should we create a new node first? Because then you can return it in the boundary condition because you'll insert it in. So how about the first thing we do is create our node? Who remembers how to create a node? I'll start. Oh, someone's already started. Excellent. Yep. Excellent. Okay, so struct node, new node is being created. malloc size of struct node. So you're calling memory allocation and giving it the size of a struct node because you're making a node. Excellent. Okay, very good. And then, oh, I didn't mean to do that, sorry. Okay, and then what do we want to do after that? We want to set the value that was given to our function as the value of this node, as the data of the node. So how do we do that? It's really hard not to jump in and I'm going to jump in briefly. I tried so hard. Okay, no, someone's doing it. Someone's doing it. Here we go. New node. Yeah. Data. Excellent is equal to the value. Very good. So that sets our value to be whatever the value is that we're given. And we should also initialize the next field as well. So let's initialize the next field in this new node. And how will we do that? How do we access the EU node? That feels very real. Yep, excellent. So new node, oh, it went from U to nothing. Yeah, there we go. New node. Oh, excellent. So new node next is equal to null. Excellent. We now have a node floating about in air. It's not connected to anything, but we know that the location of it is at the pointer new node. So now what we can do is if head is equal to null, we can insert that new node. That can be our list. Yeah. So what could we return here in that case? Okay. So if you're returning value, that's just going to give you, it's just going to give you an int. But this function returns a pointer to a struct node. So we need to return a pointer to a struct node. Yep. So return new node, which has the address of our one node, and it's set to null. So it's just going to return that beautiful node to us. Excellent. So we've taken care of the empty list boundary. Fantastic. Okay. So now we've set a current to the head. So now we're ready to count how many things there are in this list. So we might need a while condition. Yeah, fantastic. Look, no one has to hear me complain about the keyboard. This is so much better. So whilst current is not equal to null, which means you will visit every single node in the list. So important if you want to count exactly how many nodes there are. You're going to increase the counter and you're going to move it up along next. Okay. So when you exit over here, when you exit out of here, you're going to have counter is going to have the number of nodes in the list. Okay. How do you find the halfway point now? Okay. Counter is equal to counter divided by 2. Okay, so that's going to give us, the counter is going to be halved, which will, so let's say I've got 4 things in the list. Let's say I've got 1, 2, 3, 4. It's counted 4. It's going to now give me 4 divided by 2. It's going to give me 2. So what it's given me is the perfect number. If I go up to the second node, I can insert after it. Okay. Okay, very good. Okay, so now we know where we want to insert. So how do we get to this point where we're going to insert? What do we reckon? Ah, you see, I cancelled the odd number of nodes initially. I made the question easier. But if this question is in the exam, you're going to be given specifically what to do if there's an odd number of nodes. But I said there's always going to be an even number of nodes. Should I change the question to an odd number of nodes? I can. It will make it harder. We can do that if people want to. Absolutely. Hey? Yeah, okay. Well, I also want to delete a node. So as long as we get to do that. Who's highlighting? Is it me? It's not me. Is it Tom? It's not Tom. Hello. Okay, so we're at the halfway mark. No one's inserted anything yet. What do we do next? Yep, I think we need another while loop. I agree. And that next while loop is what's going to let us get to a place where we want to insert. Very good. We've reset the current to head so that we're back at the start of the list. Otherwise, we are at the end of the list over here where at current is equal to null. Excellent. Very good. Okay. Then we've got int n is equal to 0. We're doing some counting here, I think. And oh my gosh, there's now n's and i's. I can't keep up. What's I? Counter. Thank you. Okay. So while n is less than counter minus 1, okay. Current is it? Okay. Then you're going to n plus plus. So when you exit out of this while loop, what's going to be the condition? I don't know. We're thinking. Yeah. It might be minus 1 in other cases, but in this case, it is just counter because you're getting your halfway point. The counter is equal to 2, and you want to stop at the second node. So this will stop you at this condition will stop you at the second node. So then you'll increase the n. You'll do current is equal to current next. And that means at this point, you're ready to insert. Okay, so then you're going to do new node next is equal to current next. Yep, current next is equal to new node. What do we reckon? Looks good? Maybe we want to change this return. We can just run it and test it. Don't be scared to get things wrong. I'm just going to assume I'm just going to return the head for now. All right, should we compile it? It might not work. What just happened? We'll just go with that. I don't want to touch it. Okay, should we try it? Okay, well, it compiled. Okay, I'm going to run it, and I'm going to give it a list. 1, 2, 3, 4. And what should we insert? Let's insert 6. 6, 4 is what's returned. So somewhere the insertion has gone haywire. Ah, yes. Should we check where it's gone haywire? Okay, up to here was all good. Reset the current was all good. Then we got up to here, we're at node 2. So that means your current, okay, I can see where we went haywire. Let's run through if, wish I could draw it.
I'm not even logged in, bro. Yeah, I'm not even logged in, don't you know?
Okay. So let's see what's happening. Let's say we've got the list 1, 2, 3, 4, and I want to insert in here. Okay, so if we've gone through, I'm just going to go through here, let's say. Okay, so int n is equal to 1. So I'm going to say n is equal to 1. Whilst n is less than counter, counter right now is 2. So we'll check the condition, is 1 less than 2? Yes, it is. So we're going to increase n by 1, and we're going to move current along to the next node. Then we're going to check the condition again. Is 2 less than 2? No, it's not. So when you exit out, you're standing, your current is over here, and you're ready to do your insertion afterwards. So you want to insert the new node, which is 6, floating about. You want to move it into here. So On line 46 over there, you've got new node next is equal to current next. So you've pointed this one to that one. And then you've said current next is equal to new node. So you've done this one. So what do we reckon?
Oh, can we just run it once more? Like, compare it and run it.
Let's run it again. Something was changed, was it? It was. I guess that's the problem with it. It's changing as I. Okay, there we go. 1, 2, 3, 4. Let's insert 6. Aha! Someone changed it and fixed it as I was doing it. I'm like, oh, that seems to work okay, what we've done here. Okay, so how can I break it? Well, people want to make an odd number of numbers list. What happens if I make it an odd number just now and then try and insert? Will it do in the right? Yeah, so we'll insert, because if we do 5 divided by 2, it won't do, it'll just give us, because of the mod and the way division is done in C, it will just insert after that second node also. So where should it insert if it's an odd number of nodes? There is no middle, is there? Not a perfect middle. So yeah, so you would have to have a specific condition. It would tell you if there's an odd number, insert after the third thing or insert after the second thing. I'm going to move along because I want to delete a list, not a list, a node. Well, maybe a list as well. So Tom, can you copy this out into the program code as well? What got changed? I didn't see what got changed. I think someone, I didn't see what got changed. I'm sorry. Hey? Line 47 got changed. Okay, so the pointing got changed where it was leading to. Yeah. The 40th line as well. Okay, so this got changed to 1, I think, from 0, which means that it stopped before it was stopping at the wrong node, but that it was inserting in the wrong place as well. So something must have changed here as well whilst. Wow, these are so much fun. Yeah. Okay. Maybe the return was not yet updated to being the head of the list. Okay, let's try the next one. How's everyone feeling about inserting? I was returning new nodes. I was returning from the new node onwards as opposed to anything else. Tom, could you please poll how does everyone feel about inserting a node? What do we reckon? Inserting is easier or deleting is easier? I don't want to do either one. Okay, let's do this one next. Count all the elements in the linked list that are divisible by 6 and output the count. This is going to be a fast one, and then we're going to do deletion, and then we're going to do a Kahoot, I think. What? Should we do it in a full again? How's everyone in the room feeling? Do you want to do it all together or do you want me to just do it just like this? 11:25. Yes, counter -1 would have worked if n is equal to 0. Yeah. Okay, who wants to do it on REPL? There. No one. Just do it on the board? Wow, okay, the vibes are all there. Wow, you've been rejected with that idea. Okay, so let's do this one. Find divisible by 6 should return the number of items in the list divisible by 6. So again, let's do, I'm just going to get rid of that. So what are we going to do in this one? Okay, first, just so that you remember, boundary conditions. Don't forget those. And then we're going to move through the list and check if divisible by 6. Okay, excellent. Let's do it. So we're moving through the list. So struct node current is equal to head. Okay, and then we want to be able to count the number of items that are divisible because we're returning an int. So I'm going to have an int divisible and I'm going to set it to 0 because right now nothing is divisible. And then I'm going to move through the list. So the expression, I want to visit every single node in the list. So I'm going to say whilst current is not equal to null, I'm going to check whether something is divisible by 6. So if my current data is divisible by 6, so if modulus 6 is equal to 0, which means it gives no remainders, then I'm going to increase my counter here. Otherwise, I'm just going to move along the list. So current is equal to current next. Okay, and then finally, I want to return that counter that I've been counting with. Okay, let's check if everything works or if it's broken. Okay, so let's go in here. Okay, compiles, and let's do a list. I'll do 1, 2, 3, 4. Okay, 0, excellent. How do you think I can test it? Where should I test it? What should I test? Empty list, let's do an empty list, sounds good. Yep, 0, because the counter is set for 0. Anything else? How do you reckon, anything else that I might want to test? Pardon? Yeah, okay, let's have something that's divisible at the head, in the middle, in the tail. Okay, great. It's checking everything. It's checking the head, the tail, and the middle. So always make sure you check that it's checking at the head. Always make sure you check that it's checking at the tail, which is that, your while loop might be off by 1. So make sure you do those. That was such a good problem. Just solved it. What about a large number? You'd be really testing my mental arithmetic to think of a multiple of 6. Quickly, 6 times, oh, well, I can do like 6 times 30, 180. Haha. That wasn't even such a large number, but that's all I could do in the moment. Okay, fantastic. Let's go to a harder one. What about now you delete the first node in the list that is divisible by 6? Okay, so now we want to delete the first node in the list that is divisible by 6. Okay, so what do you reckon we should do? Okay. Yeah, we want a previous so that we know where to stop. We can do that, absolutely. Okay, previous is set to null. Struct node current is set to my head. Okay, in this one, because I'm going to be deleting always boundaries, just in real life and in code, boundaries always important. Where's Ben when you need him? Okay. I don't know, Tom is just standing there, sitting there and smiling. Yeah. Boundaries, Tom, boundaries.
Ben is exercising a boundary and working on an assignment right now. So.
He told me it's close to finishing. Okay. Great. What are some things that could go wrong? Let's think of what's the boundary that can go wrong. Broken record, broken record. Just the single most boundary that always goes wrong. Pardon?
Deleting head.
Okay, deleting head. Yeah, delete empty list. Oh, God. Empty list. Okay, so let's check for an empty list first. So if my head, where I spell so much better than this in real life than what you see. This keyboard is just horrific. Okay, return null. So I've got nothing to delete if head is equal to null. Okay, so we've maybe taken care of this one. I wish I knew how to tick. I'm just going to do that. Okay, then we don't know yet what happens. What happens if it's, well, let's leave it. Let's do just the common case. Yeah, so someone suggested, could we just copy paste the code to find if divisible by 6? We could. Yeah, the code is, yeah, we could do that. Or we could just, yeah, we could just write that if condition again. We can absolutely do that. Okay, so we've got our current is set to head, and now let's do our loop to find where we are. So whilst, and what should we be checking? So you're saying current is not equal to null? We can try it. I give nothing away. Okay, we want to stop maybe. We can try both. Should we try both? Let's try current first, okay? Then we can try. Should there be a second condition? Okay, all right. You don't want to put it there? Fine, we don't have to. We can put it. Okay, so whilst current is not equal to null, what do we want to do? So if current data modulus 6 is equal to 0, you want to have another now in there if current. It's not efficient, but we'll do it. Then we can fix the efficiency. I keep telling you I don't care about efficiency, but just a little bit. Okay, so if current is equal to head, which means that we are deleting the very first thing, then what do we want to return? Well, it depends. There might be other things in this list. So I don't want to return null in case there is other things following on. Yeah, so I want to return whatever is in current next, and that might return null, but it's going to return something. Okay, otherwise, okay, that's that condition. Okay, otherwise I just want to delete a normal node. And how will I delete it? Thoughts, thoughts, thoughts. I'm just going to move us along here. Okay, so we've got just the hard part now, deleting. Okay, so what do we reckon? Oh, we do. Yes, very good. We've returned current next, but the head is still floating about. We haven't deleted it. That's very good. But what happens then? Yeah, we can't do that. Why not? Yes, very good. So we can't do that because otherwise we're going to lose where we are. So we would do head is equal to current next. And then you would do free current. And then you would do return head. Okay, very nice. Okay, so back to our normal condition. If it's just in the middle somewhere, feel free to draw it up. I can draw it up as well, I guess. Let me just quickly do that. And then so let's say we're doing just a normal condition, and that means that you can do, okay, it's 7, 3, 6, 5, for example. So I'm ready to delete this one. This is previous, this is current. So how do I want to make my deletion happen? So I need to link my previous to the current next. Yep, so previous next is equal to current next. So previous next is equal to current next. And then what? Free current, yep. I always think, yeah.
Put that in the L. I delete 2 things by accident.
Well, you're returning something from here, so you're going to exit out of here. So you will capture that. And now here you will want to return, because otherwise you will delete more than one thing. So then you can return the head from here as well. Okay, should we try it? Okay, let's give it a whirl. Good God. Okay, excellent. And now let's run it. Okay, so I'm going to do a list with the 6 somewhere in the middle, so everything else is not divisible. Okay, let's see if it deletes it. Yep, so that works. What else will I try? Yeah, 6 is ahead. Yep, so I've checked that it's just deleted the head and nothing else. What else can I try? Try a number that deletes it at the tail. Why did I do such a long list? I don't know. Okay, so that's working as well. Excellent. And what else can I try? Empty list. Yep. Okay, yep. Hey, nothing divides by 6. Excellent. Excellent. Okay, so all the cases are taken care of, just squared away beautifully. Tom, could you poll, please, how we're feeling about it? What if we have 4, 6, 6? What if we have even 6, 6, 6? Okay, I mean, that's really unhelpful because we don't know which one was deleted. We hope it was the first one. So now we want, again, it's deleting the right one, but we hope it's the right one. Hey? Which one was it? Only one 6. Yep. So there's only one thing. Haha, excellent. So this is great. So you really, yeah.
What about 4, 6, 1, 1? Like 6 in the second one.
Yeah. Hey? Any other? We did that, yeah. It likes it. It's like you can't believe you've solved it. Come on, there's got to be a dereference null pointer somewhere. All right. I mean, that's a nice idea. What if we do 4 minus 6, 4, 3? It's just squared away, and you can't. You're gonna wreck it because when it converts it, it wants ints. I've just said it once, ints. Ints. This is kind of like the difficulty of a question 4. You got to search for something, you got to delete something, or you've got to insert something. And there's potentially, well, there is a few versions of the exam, so it's personalized to, I don't know, where you are, what you're sitting, and what time. Should we do a Kahoot to just kind of square it away? Oh, I hate it that it does that.
They run into the fact that you can only have 10 people playing this game. I hope not, but
What?
it did just say play with up to 10 players.
Did I?
Hopefully not.
That's what I usually click on, I thought. Wait, let me just...
We'll see if it works. If it works, it'll be good.
Well, you're Tom 1 right
Yeah,
now. You're closest to
reach.
me. What the hell?
What?
Okay, I'm sorry.
Are you logged in on an account verified as like an academic account thing?
I've never had this problem before. We do this every week. Yeah, but you don't... How will I share my... Okay. Okay, hang on. I'm going to exit out of this, and then we're going to do it again, because I don't know what it's doing. It's hating on me. Something has to hate on me at some stage. Okay, for those playing along at home, I'm about to switch off this for a second. It's about to come back, don't worry. Let me see if it's going to... doing that. It is saying 10 players. It's never done that before.
They may have just turned on the, do we want more money feature. You can see this on my...
I'll just delete one if that's... Can I send it to you?
I can do up to 20.
20? I was doing like way more. No.
I was checking. I can only do 20 as well.
We can do up to 20.
Thing ever works.
I make a crazy suggestion.
What is it?
I think there's like about 20 people in the room. All the people in here play on the Kahoot, but people in the chat can say what they think the answer is. So people in chat can like type it in and be like,
Oh, I get the glory of the podium.
it's true.
Okay, let's just do...
Yeah, each question.
Hey?
You can just do each question. Like just click through the questions.
Well, no, just whoever wants to can just play. The first 10 to log in are playing.
You know what?
There we go. Everyone else is just playing along.
Yeah.
I like this game. Can exams be like this?
First 10 people to show up to the
You don't know
exam.
which set of 10.
Imagine you just had like a set of people like camping outside the night
Yeah.
before, like lining up, like
Yeah.
waiting for an iPhone.
I reckon it's going to be a random.
People don't really want to sit an exam that badly.
A random set of 10. A random set of 10. They have to show up.
And you choose your champion. Like
Yeah.
you don't get selected, you have to choose the person whose mark you want to get.
That would actually be a good motivator to study together.
It's going above.
What?
28.
Oh, well, just keep logging in.
Keep locking in.
It's a limit. Oh, no. Okay, fine. Are we ready? Let's do it. The chosen 10. 11. The chosen 11. Ah, Tim Living Front is back.
Got him.
Starting off easy.
The music pops.
You got to be at the front.
It's such a banger.
You're going to do that.
You can change the music as well.
Ooh.
There's like different categories of music.
The difference is it lets you compile, so that's a valid piece of code. It will let you compile it. But when it runs it, it accesses a null pointer, so it's a runtime error. It will exit out of it in that case. Oh, wow. Hope you're all enjoying the, yeah.
I guess that means other people in the room could join in the first place.
That's true.
Hey.
Only people they're the only ones who knew the code.
Oh my gosh, I'm so sorry.
So nobody who wasn't in the room could see the code. The people here could all see what the code was for the Kahoot, but nobody else could.
I'm so sorry. None of these rooms, none of these. Yeah, okay, I understand you want me to pay you lots of money. What? There is, but I didn't click on that.
Okay.
Oh, well, there we go. Beautiful. Yeah, well done. Okay, okay, okay. I see people are advising me to get Kahoot++. Thank you. Maybe I will next term. But hopefully none of you are here to see me get Kahoot++ next term. Okay? Well, not next term. I mean that no one fails. I want everyone to pass and have a great holiday. I'm so sorry. Yeah, it is an in-person. Oh, we should have gotten someone to run an online specific Kahoot as well at the same time. Okay. I like how it just lets me know every single question that we're up. We need more players. Okay. I get it. Stop rubbing it in. Oh my gosh.
And Elon's next.
Okay, very good. I've got one horrible code snippet coming. Enjoy.
That was blocking the question.
Oh my gosh.
Yes, this is the sort of thing
No.
The off-brand version.
I don't know what happened. No one replied to this one. They didn't like this. There was a,
We couldn't
okay.
see.
Oh, because Kahoot was just upgrade, upgrade, upgrade. Okay, here we go. I'm ready to close that upgrade thing. What's the output of the following? Oh, this is a nice one. Just testing your mental maths on a Wednesday morning. It does it repeatedly.
Somebody tries to join.
Ooh. Almost very good. Follow your like bedmas basically. Bodmas, bedmas, whichever way you learnt it. This is really testing your understanding of size off and how arrays are. Okay. Okay, so this one is basically you're doing size of the whole array divided by size of what each element is, and that gives you. Hey?
That's like
So, because yeah, an array is a pointer to, yeah, I should have gone more into that depth.
I just established that anytime somebody types in the pin, it pops up.
Are you typing in pins
I
now?
typed it in once to see if it worked.
Okay, so it's you. It's
I
you.
have to keep on doing anything.
Hey, very good. All right, let's try it.
what's that function
Ah, I'm sorry, everyone. I'm sorry you can't log in. I don't know what Kahoot did to me this morning. I know, I'm devastated. Okay. Oh, that was very nice. Well done. Pointers. Down pat. Okay, I think this is a nasty one now coming. Maybe the nasty one's the next one. Yeah, this is the nasty one. Enjoy. This is for everyone that enjoyed the string exercise that we did on Monday. You might need to ASCII D. I gave a minute for it. Oh, one person. Love it. I mean, this was just a harsh one. If you have the ASCII table in front of you, you'd be better able to do better at that question. Okay, next one. I can't remember if this one was. I just got more harsh as I went along. I need a special helper to just close that. I'll just pay for the full version.
I have a suggestion for the final question.
Oh, very nice. You're going to access an index out of bounds.
I don't think
Okay.
autoformatting is going to help you with this one.
Sorry. This is, yeah.
If you right click on the keyboard, nothing special.
What does it output?
Error 10, 12, 15.
Yeah, error 10, 12, or 15. Why is B getting 100? Hey? Just throwing stars and ampersands everywhere, littering code with them.
Which one's error? This one. Red.
Error is red, 1. Ooh, 50. Oh, one person.
Why 50? Who you the
Okay, so you've got array A that's got 2, 4, 6, 8, 1 in it. You've got a pointer B. You've got a pointer C that's pointing to the array. So it's pointing to the first element of the array. And then pointer B is now set to the address of the second index. So to the number 6. And then you just kind of keep going with that, I think, once you get that. I can't hear you because someone is opening their bag very loudly.
Wow.
I know. Sorry.
line 10 and 15?
I perhaps went a bit too far. Some quick points over.
Is it a question error?
Welcome to COMP1511.
Welcome to COMP1521, which you will do next. Oh, apologies, I got overexcited.
Safely not in the exam.
Yeah, it's definitely not in the exam. I've been trying to be like, no, you can't do arithmetic with pointers, but here we are.
Oh, that's not stop at 6. Okay, it's at 6 now. Okay.
My suggestion for your last question, what's the output of this C
I
program?
think
Yeah, question 9. It works.
Question 115.
This inspires the game. It's a C program that defines the game. And I don't know what this is supposed to do.
Oh. Almost. Almost. Who's on the podium? Out of all the people in person, I'm sorry for all the people joining us online, you're all on the podium. Oh, hey, hey. It's Saturday. I don't know. That's showing my age. Yay, well done. All right. Overall, I just wanted to say thank you so much for all of you. Also, actually, for showing up in person. I've really appreciated it, even though we've had a lot of issues. It's just been issue after issue in these theatres. It's been really nice being back in person and seeing people's faces. The joy of programming just written all over your face. As I move nodes along. It's just been fantastic. So thank you so much. Thank you for engaging as well. I do really appreciate it. I hope you have a good break after the exams. And good luck studying for the exam. Remember, revision sessions next week, and just overall good luck. Good luck for your other exams. I know a lot of you are doing maths as well, and maybe some physics, which is just killer combo, those 3. So good luck. Enjoy your summer holiday.